Hi there. Thanks for joining us. This is Space Nuts, where we talk astronomy, space science, and whatever else turns up. Sometimes we talk about dogs and cats. Yeah. Coming up on the program today, we are going to look at the upcoming anniversary of the International Space Station and other space stations that are in low Earth orbit, because come November, 25 years of continuous occupation of space by humans. That is rather wonderful in terms of an achievement. We'll also talk about the future of the ISS, because it's not going to be around for that much longer. We're also going to look at the moon, because it might have valuable craters that could be worth mining. I don't know how Fred feels about digging around on the moon, but we will ask him. And 3D printed rocket motors, yes, they are a thing, or things are. We'll talk about all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And we once again welcome His Royal Self, Professor Fred Watson, astronomer at large. Hello, Fred.
Thank you, Andrew. Thank you. I was at an event in rural Victoria last week, and somebody, the organizer, described me as astronomy royalty. So I thought, well, I'll take that.
That's nice. Yes.
Yeah,
I didn't know that. So
it's not true, but
there's more than one person that thinks that, Fred. So.
Oh, well, that's nice too. Anyway, it was, So I'm not His Royal Highness, so I'm basically Fred, and that's how I'll stay probably for the duration.
Didn't they make a movie called King Fred or something like that?
Oh, maybe, yeah.
Yeah, some time ago.
Fred's a good name. It's in high energy physics, which kind of impacts on astronomy. It's an acronym for fast rise exponential decay. Fast rise, exponential decay. It's, I'm not sure whether that describes me or not, but that's what it's an acronym for.
It sounds more like live fast, die young. So
yeah, that's right. That's a bit,
not you.
Yeah, no, that's right. Live slow, last a long time. That's the idea.
Yeah, you mentioned before we started that there was a conference in, is it Sydney at the moment?
Yeah.
What's that about?
Yes, this is not the one I was at last week. The one I was at last week was an astronomy education conference in Melbourne, and followed up by, and a shout out to them, the Sea Lake Astrofest. It's the Astronomical Society of Victoria's annual dark sky event. And Sea Lake is a rural town, a small rural town, northern Victoria, 2 hours drive south of Mildura. And I spent a glorious weekend there with a lot of like-minded people talking about astronomy and space. What's on this week, though, I haven't been invited to, so I can't be that much astronomy royalty. It's the International Astronautical Congress, and this is a major international meeting. I think there are 11,000 delegates, so whoa. It's on at the Convention Centre here in Sydney, and a lot of really fascinating stuff being discussed and described. Some extraordinary technology turning up in there. It's a showcase for the world of astronautics, and but it's very much space orientated. But it was that in mind that I chose the three topics that we're going to talk about today, because I thought they all relate to astronautics and space flight.
11,000 delegates, did you say?
Yeah.
That's a lot of plastic chairs.
It is, yeah.
IKEA must be thrilled.
Probably. Yeah. Sorry, go on.
I was going to say, you got to wonder about organising something like that. I mean, the logistics alone.
Now, I used to, when I was a sort of, proper productive astronomer doing real work, rather than just talking to you, I used to go to conferences organised by an organisation called SPIE, which was originally, the Society of Photo-Optical Instrumentation Engineers, I think, but they in the end just called themselves SPIE. And they were, so I used to build astronomical instruments, mostly involving fibre optics and things of that sort back in the day, which eventually turned out to be quite productive, and we did some great surveys with some of them. But the the annual conferences for instrumentation people were these SPIE conferences. And I think the last one I went to, which was probably 20 years ago, already had more than 4,000 delegates. And it felt like, you know, you didn't really know anybody. The early ones, you kind of knew most of the people there. But with 4,000, you didn't know anybody. And the other thing that about big conferences that always I struggle with is the parallel sessions. So you've often got 3 streams of sessions running. And if you want to catch the papers and presentations, you've got to be ducking in and out of doors and standing in the back of rooms and things like that. And I'm sure the IAC will be like that this week as well. It's not my idea of a party.
I can imagine, yeah. Anyway, I'm sure it will go well. Speaking of space and things in space, we are looking at, in November, 25 years of continuous occupation of space by humans. And we're talking about the ISS amongst other things, but there's more than one space station up there now. So it will continue even when the ISS is decommissioned in a few years' time. That's an extraordinary achievement.
Isn't it just, 25 years of continuous occupation in space. It tells you that we are a world or a species that's able to face the challenge of getting off the Earth and getting off our home planet and into space. Even though, yes, for those 25 years, what's the ISS done? It's gone around in circles. But yes, the fact that it's up there, it's about a height of 400 kilometers. It's still within the Earth's protective shield magnetically, so that we're within the radiation belts. But it's still the vacuum of space. It's a very challenging environment, and we've made it work. And it's once again, I think one of perhaps the best things about the ISS, particularly in this day and age, is just a model of international cooperation.
Yes.
Still, those major players of European Space Agency, NASA, Roscosmos, the Russian Space Agency, then JAXA, the Japanese Space Agency, and the Canadian Space Agency. They're the main players in the ISS, and they're working together. And, in the environment that we're in now, that's a shining example that I hope continues beyond the end of the ISS.
Yes, and Australia has been involved as well. We've had a couple of people up there, I think, and just as I was thinking of their names, it all drops out.
Yes, they do. So Andy Thomas was
yes,
one of Australia's astronauts. I think he flew on the space station. He's best known for his missions to the Mir space station, which was a kind of precursor. Yeah. And Paul Scully-Power, another Australian grown but NASA employed astronaut. Paul's a character and a half. I've met him a few times, hung out with him once. I'm sure he led me up to some bar somewhere that I never thought we'd get away from. He's a great guy. But of course, we now have Catherine Bennell-Pegg, who is also selected for the astronaut corps. She is an Australian astronaut we all hope she'll fly quite soon. She's very enthusiastic, a fantastic mentor for young kids, especially young girls. Yeah. Doing great work in STEM. So yes, we've played a part. But you're right. It's not the only thing up there. Of course, the Tianwen, it's Tiangong, isn't it? I should get the name right. Space station, the Chinese space station, which has been in orbit actually for probably 3 or 4 years now, I think. And that's a growing enterprise in China. It is Tiangong. There's Tianwen's a spacecraft that's actually going to rendezvous with a near-Earth asteroid not very far down the track. So I've got all these names in my head. I'll pick the wrong ones. It's about the same height, 400 kilometers above the Earth's surface. Crew of 3, compared with the crew of the International Space Station, which is normally 6 people, but there was one stage this year when it was up to 11, with people kind of camping out in different bits of the space station with finding somewhere to sleep. But it's big enough that you can do that and still have a bit of privacy about it.
Yes.
So, it has been a fantastic resource. A lot of people in the early days complain, what's it doing? It's just going around in circles. It's conducted more than 4,000 experiments, and for more than 4,400 research publications, which have come about, many of which are about quite earthy things, how medical issues, things that we might learn from our occupation of space that will help to improve our life down on Earth. It's been terrific. So the end of the road will come in 5 years' time. I'm not sure what time of year, but 2030, the plan is to deorbit it and to send it down into that sort of graveyard region in the Pacific Ocean. It's that point that's the furthest away from land of any part of the ocean on the whole of the planet. And there's a lot of space hardware on the floor of the ocean there, and it's going to include the International Space Station,
Okay, so they probably won't recover it. Be fairly deep there, I imagine, but they're bringing it back down. But that won't end the presence of humans in orbit because the Chinese will be there, and NASA is working with private companies to put more hardware in low Earth orbit.
That's correct. Yes. So, commercial partners is the watchword, as we've seen from ferrying astronauts up and down to the space station. The way we've got both Blue Origin and SpaceX as major players in the Artemis program. So all of that is in place. I think there's something called the Phase 2 partnership. Which is proposals for commercial space stations. And that NASA apparently issued their draft announcement of this Phase 2 partnership this month, September 2025. So that will allow companies to get funding to do critical design reviews, maybe demonstrators. One of the demonstrators that we're hearing about is the idea of a 4-person space station with a lifetime of at least 30 days. So it is. It's an ongoing business, and I think you and I are going to have a great time in the next 5 years because we'll start to see what is coming up as being the replacement for the International Space Station. It could even be an inflatable module.
I know they were experimenting with that.
They were, that's right.
That.
This
sounds pretty good.
Yeah, well, it sounds ridiculous to me, but apparently inflatable space stations are actually more resistant or more resilient to space debris than solid ones because you can make the fabric of which you construct it. You can make it out of many different layers, including, the bulletproof material and things of that sort. And in some ways, it becomes self-healing. You put a hole in it, and it just goes, and comes up the hole.
Like that stuff you used to put in a car tire. What was it called? Finillique or something. You got a flat, and you just pumped it back up, and it was fixed.
Yes, I've heard from people that didn't always work terribly well. When we discovered that Marnie's Suzuki doesn't have a spare wheel a couple of weeks ago because she had a puncture. Anyway, that was a different story. But was it Bigelow? I think that's the name of the company. They back 20 years ago were, in fact, they launched 2 spacecraft whose names I can't remember now, which were basically aimed at the space tourism industry, to have an orbiting hotel which was basically constructed of fabric rather than solid metal. And I think the 2 of them are still up there actually. I think they're still in orbit. Yeah, no people on them. One of them was filled up with bits of paper with people's photographs on and their names. So you could see a photograph. There was a camera that showed all these things floating around in 0G.
Yeah. Oh, look, the space hotel, that's going to be a thing for sure one day.
I think it
no
will
doubt
be.
about it. And But 25 years of continuous human occupation of space and counting. It's going to, and the other point is, in those 25 years, there has never been a time where there was not an American in space.
Yes, that's true. That's true. Yeah,
that too is impressive. Yes.
Yeah.
All right. You can read all about it in a great article on theconversation.com. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Let's move a little further out from low Earth orbit to our one and only natural satellite, the Moon. And it's being looked at with very, very, what's the word I'm looking for? Enticing attitudes. They want to look into the craters because they think that those craters may contain some rich deposits of precious metals that we could probably use.
Yeah, I love the logic of this research, Andrew. It's kind of flawless, really, but it's something that we haven't thought of before, and that is that people have been thinking, perhaps for the last 15 years, about the metal and mineral reserves that we know exist on asteroids. And 15 years ago, I'm sure you and I talked about it, probably when you were on ABC Western Plains then, rather than the podcast. There were companies set up. One was Planetary Resources. Deep Space Industries was another. I think they've all been taken over by blockchain companies now. They're not really active anymore. But the idea was to set up a kind of off-planet economy where you go and mine these asteroids for resources. But there are all kinds of pitfalls with even these near-Earth asteroids. It's actually, for a start, they've got so little gravity that any mining apparatus that you put on it risks just floating away as it tries to dig up stuff. They're quite complicated to reach as well, even though the near-Earth asteroids, of course, come near the Earth, but that places some demands on the astrodynamics needed to get there. Here's the other thing, and this probably is one of the things that makes it difficult. They tumble in space. They're all rotating. Sometimes if you've got a small one, they'll rotate once in not just a few hours, but a few minutes really. And if you've got something on trying to stick onto it and dig holes in it, that's quite a challenge. So here's the logic, though. If we think that there are valuable minerals in asteroids, why don't we go and find the debris that is left by asteroids when they hit the moon? And that is the material that is in and around lunar craters. So this is research that's been done by, I think it's a team. I think there are universities involved, but I think it's an independent astronomer who's led it. If you think about the craters of the moon, you can actually analyze a lot of what their geology is like from above just by looking at the spectrum colors of the rocks. You're basically doing something called spectrophotometry, where you're breaking up, basically using filters to find them. And they suggest, these researchers suggest that there are up to 6,500 impact craters that might contain the platinum group metals like rhodium, palladium, and platinum itself. And they also suspect about half that number might be water-bearing, that they've got hydrated minerals in it, and it's a molecule that basically you can extract water from. And so, in fact, what the team writes, and I'm reading here partly from Michelle Starr's article on Science Alert. Michelle Starr, one of our heroines, I think, in terms of science journalism. She's written a very nice article on this, but she quotes one of the team members. These numbers, the 6,500 and about 3,400 impact craters with water, these values are 1 to 2 orders of magnitude larger than the number of ore-bearing near-Earth asteroids that we could effectively mine. That implies that it may be more advantageous and hence more profitable to mine asteroids that have impacted the moon rather than the ones that are in orbit. And so, yeah, that's a really interesting idea.
It is. Yeah.
And as you said in your intro, there are ethical considerations with this as well. I'm interested in your view of that, Andrew.
What, mining the moon?
Yeah.
Well, it takes it away from Earth, and it's got limited resources, and there's a lot of controversy about mining the moon, mining the Earth because of the environmental impact, because so many creatures, including humans, rely on a decent environment. Yeah. Mining the moon, not the same problem. I'm not that much against it, to be honest. I think if there's stuff there that we need and we can use,
I think
maybe we should have a crack.
I think I agree with that. I still think the moon needs to be handled with great care, in the sense that. Except we're not mining Antarctica, because I was about to.
Not yet.
No, well, not yet. That's right. So, do you want to pass legislation that says the moon is used for purely scientific purposes, or do you want to open up the possibility of maybe limited mining in certain areas? It's something I'd be ambivalent about as well. I think, I don't think I'd rule it out completely, but I think it would have to be done within an ethical framework. And that to me means international collaboration, which we don't have at the moment.
No.
What we've got is a race to the moon, effectively. And perhaps this is one of the, carrots that is dragging that race to the moon along, or accelerating that race to the moon.
There are already things on the moon that we see as valuable that don't exist or are easily accessible on Earth. So that's another thing that's probably got them rushing there.
Yeah, you're probably thinking of helium-3, the rare isotope of helium that has the promise of cheap fusion reactors, cheap and safe fusion reactors because of the low levels of radiation that they emit. That's still an unproven technology. I don't think we've got enough helium-3 on the Earth to build a reactor. It's very rare on our planet, but it's thought to be fairly prolific on the moon because it's formed from the solar radiation. Yeah. That's another issue. So yes, I think I'd be certainly open to the debate, but I would like it to be in an international forum. And maybe the forum would be the one I was involved with a couple of years ago, COPOAS, the Committee on the Peaceful Uses of Outer Space, which is a subset of UNUSA, the UN Office of Outer Space Affairs. One would hope that they will be deeply involved with something like this, and that some sort of consensus might emerge from it.
Yes, I hope so. Of course, if they do end up going up there and digging around and going, this is just junk, it's just, maybe the dairy industry will find something yeasty. So
I think that is quite a leap of
I don't know. When I was a kid,
I thought the cow jumped over the moon. It didn't actually land on it.
No, I was told that the moon was made of cheese.
Cheese, yes.
Anyway,
there you go.
There are all sorts of possibilities, but the possibility of water.
That's right.
In some of these craters too.
Yeah. And I think Artemis 2, Artemis 2 is going to be a flyby. Artemis 3, the first landing on the mission, we hope in about 2 years' time. If Blue Origin and SpaceX get their act together with their respective lunar landers, which are still quite a long way from being ready, that could start to tell us, because naturally there'll be samples coming back, which will be checked for all these hydrated molecules, and perhaps just for ice itself, because you're going to be near some of the craters that have never seen sunlight on the moon's south pole. Yeah, so we're in a really interesting time, Andrew, and so much ahead that may or may not come to fruition.
We will wait and see. You can read all about it in the paper that's been published in Planetary and Space Science, or you can read the article at sciencealert.com. This is Space Nuts with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Our final story on this episode, Fred, is about creating a new rocket motor. But this one's a bit different. They're going to 3D print them, and it is an Australian project.
That's right. 3D printed rocket motors are not new. There's, I think, Rocket Lab in New Zealand might be doing them, and possibly Gilmore as well here in Australia. But this is different, and it's a first of a different kind. Because this blows my mind, I have to say, it's a 3D printed rocket motor made out of two different metals. And as I understand it, as in the 3D printing process, you can lay these metals down independently and maybe even mix them, but I think you can structure the thing so that the different bits of it have the metals where you want them to be. Which is an extraordinary thing. There's a lot of things that surprise me about this story, Andrew, which is actually on Space Connect, which is an Australian homegrown space website. The first is that this work has been done by using an off-the-shelf 3D printer. And it's apparently called a Nikon SLM Solutions SLM 2080 2MA metal printer. The fact that you can buy something like that is just, a reflection of the era that we live in. And it may well be that some of our Space Nuts listeners are in the 3D printing industry, and they might say, oh, this is old stuff. This is completely old hat. And I have to say, back in 2000, when we were building the 60F instrument for the UK Schmidt telescope, remember I used to build instruments, we actually did 3D print some of the components for that, but they were made of plastic effectively, but it was a really good way of doing it. And it was one of our scientists, Dr. Will Saunders, he suggested the 3D printing process, and it turned out very successfully. So 3D printing is not a new technology, but the fact that you can go and buy something that will print with two different metals, to me, blows my mind. So Space Machines Company is SMC, and they are the delivery agency for this new facility, and it's in partnership with our National Science Agency, the CSRO, Commonwealth Science and Industrial Research Organisation, with some number of colleagues from there I was with last week at the conference. So CSRO and SMC, Space Machines Company, have built this thruster for something called the Optimus Viper spacecraft, which is an Australian-built platform designed for on-orbit inspection, servicing, and logistics, as we read in their blurb.
It sounds like a cool spacecraft.
Yeah, it does, doesn't it?
Viper.
Yeah, I like that too. So it's really, I think part of this is, and we hear this a lot these days, it's our sovereign capability. We're striving to build a sovereign space capabilities by developing, manufacturing and operating space technology right here in Australia. That comes from Darren Lovett, who is the executive director of something called iLaunch. iLaunch is basically a collaboration. I'm very glad to see that one of the universities I have an adjunct professorship with is part and parcel of it. The University of Southern Queensland and the Australian National University are involved as well, along with the University of South Australia. So a big partnership that is sort of masterminding, if you like, some of these new technologies. But yes, to see this little thruster, and actually on the Space Connect article that I just referred to, there's a very nice photograph of it. A little chunk of metal, quite complicated shape, very interestingly presented, and no doubt will do its stuff admirably when it is in space.
Yeah, combining two metals in a single build, brazing of copper and steel components. So it's not, that's tough stuff.
It is. It's steel for strength and copper for thermal conductivity, as I understand it.
Yeah, that's impressive. Yeah, that's a great story with a great Australian connection, and no doubt another giant leap forward for humankind in the space race. And you can read about it, as Fred mentioned, at Space Connect online. And that's about all we've got time for. Fred, thank you very much.
So thank you. We'll take our bimetallic thrusters and zoom off into the wide blue yonder. Good to
we
talk.
will indeed. Good to talk to you too. And we often get suggestions from people asking about stories or things that they'd like us to talk about. So if you do have something in mind that you think we should cover, or if you spot something in the media that we don't, that you think is worth a mention, we'd encourage you to jump on our website and send us the details, and we'll see if we can chase it up. More than happy to do so. Saves us a lot of work. And also, sorry, Fred, go on.
No, yes, you're quite right. It saves us a lot of work.
Well, if we're talking about what the audience wants us to talk about, that's all the better. All right. Thanks, Fred. We'll see you soon.
Sounds good. Thanks, Andrew.
Fred Watson, astronomer at large, and thanks to Hugh in the studio, who didn't turn up again today because, he got arrested by a copper. And from me, Andrew Dunkley, think about it. Yeah. Thanks to your company. We'll see you on the very next episode of Space Nuts. Until then, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.